Okay, break time's over. Get back to your desks. Nick, if you can make sure that the door is ajar so that people can go back in the restroom. Okay. Erica, you alright?
Yeah, it's cold here.
Oh, I'm sorry. It's warm to be honest. Okay, let's get down to business. So, up to this point, we've multiplied on the outside, and we've added on the outside. Now I heard the suggestion to add on the inside of the equation. Now this one is probably the hardest of all the different things we'll look at. This is probably the most challenging one to understand. So we're going to take our time with this and be careful. So, what if I have y equals sine of x plus 1? What's going to happen? So, first of all, I want you to make a prediction, tell a partner, or share your prediction with a partner, and then graph it, and let's see what actually happens. Okay. Okay. It is rolling, right? Yeah, cool. Well, you know, I'd be super upset if I thought I was recording a class for an assignment due on Sunday and I wasn't recording. That would make me sad. Okay. So, I'm only recording you guys. I recorded third hour once, just haven't recorded you guys yet. Okay. All my classes are special. Special is the word on that, you know? Okay. So, okay, I'll go ahead and draw what I see. Let's see if we can figure out what happened here. Blah. There we go. Okay. So there's sine of x. Now what is sine of x plus 1? Okay, so it looks like it's interesting. So like the peak is now right there. It's going down to the same spot. Going back. Going down. Back like that. I'll wait for the fast go back. Okay. So what happened? Oh, did not quite go up that far. Oh no, that's okay. So what happened here? First of all, did its amplitude change? Clearly, amplitude didn't change. The distance from the center line to the peak is still 1. Okay, what about its period? Did the period change? Remember, the period is how many cycles, or the period is how long each cycle is. But the distance from here to here, from the beginning to the end of the cycle, hasn't changed. Did it move up or down? So what did happen? It shifted horizontally. It shifted. The question then is, how did it shift? Did it shift left or right? Ooh, kind of hard to tell. Okay, well, let's see if we can solve this mystery. So we're going from 0 to where? How far out does it go? 2 pi. What is 2 times pi? Okay, so what is pi? What does pi equal? What number does pi equal? 3.14. Okay, so 2 pi then would be that times 2, 6.28. So that means that we're going from here about to 6. Yeah? So then about how much is that distance there, you think? Looks like it could be about 1. Those of you with Desmos, you can click there and there, and you'll see that their distance, their distance is 1 apart. Make sense? So if this is our starting equation, how did it move? Which way did it shift? Left or right? To the left. So adding 1 caused it to shift left by 1. That seems kind of backwards, doesn't it? You think right is positive, so adding should make you move right? Well, it's actually backwards. Adding will make you, or subtracting is what makes you move right, and adding is what makes you move left. And I just told you what happens next. Dang. Well, let's test that. Let's make sure I'm not talking crazy, because I do so often do that. So let's try subtracting. What if I have sine of x minus, give me a number, any number, 2. Let's try graphing that and seeing how it shifts. Y equals sine of x minus 2. Okay. So how did it move that time? It moved to the right by 2. Make sense? So adding and subtracting a number to the x causes it to move left and right. Now this has 2 different names. The name that we're going to use for it is going to be the horizontal shift. So I'll use h as the horizontal shift. So if I add, will that cause it to move left or right? Left. If I subtract, will it cause it to move left or right? Right. Yes. And it is the horizontal shift. Okay. Good. Okay, so let's try something really quick. I want you to try, let's try a horizontal shift by 2 pi. Try graphing both of these guys. What's going to happen here? What the heck? Do you see it yet? They're the same thing, aren't they? Well, that makes some sense, doesn't it? How long is one period for this guy, for this function? 2 pi. So I moved it to the right by 2 pi. So it's overlapping exactly on itself. How about that? And we saw that in a formula on Monday. Sine of theta is equal to sine of theta plus 2 pi. Fair enough? Remember that? So we just saw that, evidence for that graphically. Isn't that cool? Okay. How about sine of x minus pi over 2? What's that going to look like? Graph that too for me.
So, would you just put pi over 2, or would you put parentheses pi over 2?
Oh, when you're plugging it into the calculator. The calculator knows the order of operations. So for those of you in the calculator, you could just have sine of x minus pi divided by 2, and that would work.
Okay.
But it would be better to have the parentheses around just to be safe. That was a good question. So, let's see. So we moved it by pi over 2, and now it's starting at 1, isn't it? Starting at 1, going down. Whoa. Starting at 1. Is this right? Starting at 1, going down. Whoa. And back up like that. So, what does that look like? What is that thing that looks just like sine, but it starts at 1 instead? Cosine. We just showed graphically that this thing equals cosine. Make sense? So hopefully that helps to make sense of some of those formulas we looked at the other day. Those formulas weren't just pulled from whole cloth. Those formulas were made, or we can figure out those formulas by looking at the graphs and how shifting changes the graph. Fair enough? Okay, so moving on from horizontal shifts. Okay then, up to this point, we have multiplied on the outside, we have added on the outside, we've added on the inside. What else could we do? Any more ideas? We've done a fair amount of stuff here, so might be kind of hard to figure out these last few things. Any ideas? Let's try multiplying on the inside. What happens if I multiply a number next to the x? Okay, let's do it. So we have sine of x. Let's try sine of what? What should we multiply it by? 2. Let's say 2x. Okay. So before, as usual, before you graph it, I want you to come up with a prediction. What do you think is going to happen? How do you think it's going to change? Then once you've made your prediction, once you've shared it, go ahead and graph it and let's see what it looks like. I think this one's probably my favorite of the whole thing, of all the ones. All the transformations that we've looked at so far today. Is that okay? Interesting. So, Nicole, in your own words, what do you think is happening? What happened? Well, here, that long one, that's the one we started with, that's sine of x. And this one is sine of 2x. So what happened? How's it different? Yeah, how does it look different? How did it change? It's smaller. So, what do you guys think? How did it change? Not skinny, did it? Okay. Oh, right. Okay. Marker. There we go. So, Okay, so once again, we're starting with sine of x. Starting at 0, up and down and up. Up and down and up. Something like that? Okay, so what happened when we multiplied the x by 2? How does it look different? It kind of condensed, it got scooshed. I got it. Okay, so it kind of squished together, didn't it? So, instead of just going up and down and up from here to 2 pi, it's doing it a lot faster now. It's going up and down and up and down and up, like that, yeah? Same thing on the left side. Okay, so barring my absolutely horrendous artistic skills, did the amplitude change at all? What's the distance from the center line to the peak?
1.
Still 1. So did the amplitude change? These two. Oh. So did the amplitude change? The amplitude didn't change. Okay. Did it move up or down? Did it move left or right? It didn't. We look, both of them are still starting at 0. See that? So, what did change?
Oh.
What's the word? So each cycle got shorter, didn't it? What was the name of the length of the cycle? Period. So the period changed. Okay. So kind of the key for thinking about these changes to period is that the number here does not represent the period. This number represents the number of cycles that there are between 0 and 2 pi. So we went up and down and up and down and up. So we had 2 cycles from 0 to 2 pi. And we have a 2 right there. Fair enough? So go ahead and try graphing for me. Y equals sine of 3x. How many cycles do you think there will be between 0 and 2 pi? 3. Go ahead and test it. And we should probably erase that one. So that your screen doesn't become a massive black pixels. Okay, so how many cycles are there? How many cycles are there when we multiply x by 3 between 0 and 2 pi? There are now 3 cycles there. Up and down and up, up and down and up, up and down and up. Fair enough? Okay then. So, okay, that's great. What does it mean if we have something like, we've multiplied by numbers larger than 1. What happens when you multiply by something less than 1? What do I get if I have sine of 0.5x? What's that going to look like? We shall see. Okay. So again, compared to regular old sine. So what does it look like? Yeah, it got wider, didn't it? So how many segments are there between 0 and 2 pi? One whole segment from here to there? So look, so the segment here, this is just the first half of one, right? So when we have a big one like that, that is only half of a cycle. Make sense? And hey, look, 0.5. So we need, but what is the period of this guy? What is the length of one cycle for this guy? Is it a half? A half is itty bitty tiny. A half is like that. Remember, we're going from 0 to 6 here. 2 pi is starting here and ending there. We're starting here, or we're starting here and ending way out here at 4 pi, aren't we? So this thing has a period of 4 pi. So here's the important thing. If there's one thing you remember about changing the period, it's this. This number in the middle, I'm going to break out green, is not the period. This number is called the frequency. So the frequency just basically means, hey, how many times will this oscillate in, or how many times will it wiggle, if you will, up and down and up, between 0 and 2 pi. So this guy, just sine of x, that one goes up and down and up once from 0 to 2 pi. If we have a 0.5, well, that happens half a cycle. If we have sine of, 15x, how many times will this one cycle there? How many times will this cycle from 0 to 2 pi? This one will go 15 times. So it would look, Make sense? It'd actually be denser than that. I only have like 8 cycles right there. So this number is called the frequency. The number we multiply x by is called the frequency. But the frequency isn't something that is really all that useful to us, believe it or not, in a lot of mathematical applications. It's handy. But it still needs a letter, so I'm going to go ahead and give it a letter. F is already taken by, f of x. This one, the letter we're going to give it is B. And this is the frequency. Okay. Deshaun is off to concessions. But it still would be nice to be able to relate the frequency and the period. It's actually a pretty simple formula. The frequency, which we're calling B, if we take the frequency and divide 2 pi by it, then it'll spit out the period. Make sense? Where the P here is the period. So for example, 15x, if we have something with a frequency of 15, then its period would be 2 pi over 15. Make sense? That'd be the length of one cycle. Okay? Okay. And now, let's see. So what can we do? Now we can move the equation up and down. Or we can move the wave up and down. We can move it left and right. We can stretch it up. We can squish it down. We can compress it inwards. And stretch it outwards. We can flip it upside down. What else even is there to do to it? Nothing really. With this one equation, with this one equation that we've developed today, we can draw any sine wave. This is the general equation of a sine wave. Fair enough? Now, we learned earlier from the horizontal shift that sine and cosine, those two are the same thing, that are just shifted a little bit. Which means that all of this stuff still applies just as well to cosine. Cosine works exactly the same way, no changes. It just starts at 0, or it starts at 1 instead of 0, which is where sine starts. Okay, so we are almost out of time. Remember, I will not be here tomorrow, so I'll see you guys on Monday. Unless I get hit by a meteorite or something. So what I'm going to do is I'm going to put up a graph. And I'm going to want you to write down the equation of the graph that I give to you. So up to this point, you've been graphing equations. Let's do it backwards. Sound good? So let's say that I have, while I'm writing this, today's Thursday, so what does that mean? I'm saying after today, if anybody wants some help in this or any other class, you can come on by. Okay, so let's say that I have a graph that's starting at 0, or that between 0 and 2 pi has 1, 2, 3, 4 oscillations. Let's say that it's going up. Okay, that's a good start. And I'll put up one more. Okay, I want you to find the equations for these two waves. Oh, probably say words. So, the bell rings. I want you to show me show me what you think, what you got. See if you figured it out. So, we have the 2 to 3. There's 4 cycles between 0 and 2. Minus 1. Not minus 1. There's a couple ways we can look at this, actually. So, it looks like it moved to the right by part of the cycle. Moved to the right by how much of the cycle? By a quarter cycle. How long is a quarter cycle? 1.5. You know something really important? starts with an E, ends with an I.
Oh.
Moving it to the right by half. So actually, that would actually lead to this equation would just be okay. Show me what you got. Not too bad though. It actually wasn't shifted up or down at all. +1. So anyway, I'm gonna go ahead and stop the recording now because class is over. I'll have a fantastic day, Mr. Velasco. And that's it.